Well, here we are at trains again, but then I guess this is relativity, so you've got to have trains. It's a complex situation, there's no question here, it's just a situation that could have many questions asked of it. So just pause the video here and take a moment to get your head around this question. Okay, the key here is that this diagram is viewed from the frame of reference of this person here on the platform. So be careful, because what you see, you have to interpret it through understanding it's from this frame of reference. So the person on the platform thinks that they're stationary and the train is going to come whizzing past them. Now in their frame of reference, the train's length is exactly the same as the platform. So the red trigger and the red sensor and the blue trigger and the blue sensor are going to go off at exactly the same time. So the person on the platform is going to see the two events, the red and the blue flash, as simultaneous. However, so our red light beam is going to start out at exactly the same time and travel the same distance as our blue light beam. However, they're going to realize that that train is moving on. And so the person's face is going to run into the red flashlight first. And then at some time later on, the poor old blue one that's struggling to catch up to him is going to arrive at his face. So that person will see the flash guns as simultaneous, but the arrival of the flashes at the person's face won't be simultaneous. They'll see the red illuminate and then they'll see the blue illuminate. Okay? That's happening with that question, or that part of it. However, if we want to interpret what would happen from this person's point of view, from the person in the train's perspective, then it's going to be quite different. First of all, remember, when we're reviewing it from this frame of reference, the platform frame of reference, they see moving objects have their length contracted. So they actually seeing the train contracted, and its contracted length matches the platform. Now, if we're going to swap the frames of reference, first of all, if I'm in the train, I'm not going to see the train contracted at all. I'm going to see the train as its normal length. On top of that, I'm going to look at the platform and I'm going to see that the platform has been shrunk down in length. The platform is now shorter. So this is what it would actually look like from the point of view of the person in the train. Remember, the person in the train is going to see the platform traveling towards them in this direction here, okay? So as the platform travels towards them in this direction here, can you see how the red flash gun is going to go off first, and then sometime later the blue flash gun is going to go off? So completely differently to the person on the platform, the person in the train is going to see the two flash guns as non-simultaneous. Remember, the other guy saw them as simultaneous. This guy is going to see them as non-simultaneous. He's going to see the red one go first, and then he's going to see the blue one go. So he's going to see the red one go, and the red one's going to take some time to travel to that kind of distance. And then at some stage later on, the blue one's going to go, and it's going to take off. But remember, the red one's going to have gone further because it started off earlier. So the person in the train is also going to see the red flash illuminate his face and then the blue one. Actually, they both agree upon the arrival of the flashes at the person's face. One of the things about simultaneity is that frames of reference actually only disagree upon events that are separated by some kind of space. If two events are at the same point in space, then people will agree, every observer will agree upon whether they were simultaneous or not. So everyone actually has to agree that the red arrives and then the blue arrives. That's something we could take a photograph of or a video of, and we could see the red arrive and then the blue arrive. Okay, it's the same point in space. But what they disagree back from the person in the train's point of view, what he disagrees about is the simultaneity of the events that are separated by space, the firing of the red flash gun, and then sometime later on, the firing of the blue flash gun. So they agree upon the arrival, red first then blue, but they disagree upon the simultaneity, the flash guns going off, and then there's a whole lot of questions, what would you see from each person's perspective, who would see what happened first. What's the key to this? The key is to always think about what frame of reference you're going to put yourself in, and to realise that the length has been contracted, and that is a mirrorable object. It's very easy when you first read this question to just take as a kind of fact of absolute sort of Newtonian physics, is that the lengths are going to match in every frame of reference. Of course they don't match in every frame of reference, because in this frame of reference the other object is moving, and so you're going to see the moving object contracted, which means they're going to disagree about whether the platform and the train are the same length.